Okay, hey guys, so today we're going to be talking about day 5 notes, the different types of redox reactions that we have. So the first type of redox reaction that we have is synthesis. So it's also called combination or composition. Okay, so synthesis means to put together. Okay, so whenever you think of a synthesis reaction, you should always think of two or more elements or simple compounds that combine to form one compound. So your general form is going to be A plus B yields an AB compound. So your identifying feature for synthesis is going to be that you only have one product, and that product is going to be your AB compound. Okay, so your analogy is that a boy and a girl come to the dance separately but end up dancing together. Okay, so chemically, if you want to look at it chemically, we can take a look at magnesium plus oxygen yield magnesium oxide. Okay, so again, you have element A plus element B combining or joining together to form one compound. That's going to be synthesis. Okay, and then again, you also have another example. The combination of iron and sulfur form iron sulfide. Okay, so again, you have the keyword combination, and you're bringing together iron and sulfur to form a compound. Okay, so the next type of redox reaction we have is decomposition. So decomposition, okay, whenever you think of decomposition, you should think of something decomposing or something breaking apart. Okay, so in this case, decomposition would be one compound is broken down into two or more simpler elements or compounds. So our general form is going to be the opposite of synthesis. You're going to start with a compound and we're going to separate them or break them apart. And your identifying feature is that you only have one reactant. So again, it's the opposite of synthesis. Okay, so we are breaking down our compounds into elements or smaller compounds, or different compounds rather. Okay, so your analogy is that a boy and a girl come to the dance together, but they argue, okay, and stay apart the rest of the night. Okay, so again, they are separating. They start together, but they separate after the reaction has occurred. Okay, so just like taking a look at sodium chloride as a compound are going to break apart or separate into sodium and chlorine. Okay, and then you also have potassium chlorate is going to separate into potassium chloride and oxygen. Okay, so you only have one reactant that breaks apart into several products. Okay, now our next example, our next type of redox reaction, we have combustion. So when you think of combustion, you can think of fire, so it's also known as burning. Okay, and it always follows the same form. You're going to have a compound containing a carbon and a hydrogen. Sometimes it has an oxygen, but rarely. Okay, so you're going to have a compound plus oxygen, and that's going to produce carbon dioxide and water. Okay, and this is a very important note right here. Okay, so in a combustion reaction, the compound always burns oxygen gas and always releases carbon dioxide and water. Okay, during incomplete combustion, carbon monoxide is also produced. But really the important thing here is that your compound always burns oxygen gas. Okay, if you've ever noticed, if you play with fire, your flame will not survive if there is no oxygen. Okay, so oxygen is the fuel for combustion. So no oxygen, no fuel. Okay, and your two products are always going to be carbon dioxide and water. So automatically, just by looking at your equation, if you see that your only products are carbon dioxide and water, then it's going to be a combustion reaction. Okay, and then again, your examples show that. Okay, you have two compounds that have a carbon and a hydrogen. Okay, one of your reactants are also oxygens, and then your products are carbon dioxide and water. Carbon dioxide and water. Okay, so as far as the quiz goes in our class, that is where it stops. So really, the only thing you need to know for day 5 for our quiz is going to be these 3 terms: synthesis, decomposition, and combustion. Okay, but we are going to have to balance combustion reactions on our test. So we are going to go ahead and continue our notes. Okay, and let's go over our combustion reactions on how to balance them. Okay, so your first step is always balance from right to left. Okay, so we're always going to start on our product side of the reaction. Our next step is to balance the hydrogen first by placing a coefficient in front of water. Okay, if that coefficient in front of water is odd, we are going to double it and then proceed with balancing carbon, then oxygen. Okay, so if it's even, you're going to leave it alone and proceed with carbon and oxygen. Okay, and then number 5, always balance oxygen last. Okay, so really what this is all saying is that we are going to balance hydrogen first. Make sure that your coefficient for water is even. If it is not even and it's an odd number, you're going to have to double it to make it even. So let's say we have a coefficient of 9. If it's 9, well, double it to make it 18 and even. Okay, once you have balanced hydrogen, then you can go ahead and balance carbon, then oxygen. Do your coefficients for carbon and oxygen have to be even? No, they can also be odd. It's only for hydrogen that they have to be even. Okay, so let's go ahead and take a look at our example number 1. Okay, so we have C7H14 plus oxygen 2 yields carbon dioxide and water. Okay, so our first step is to balance hydrogen. Well, we have hydrogen, we have 14 hydrogens on our reactant side, and we have 2 hydrogens on our product side. So if this is 14 and this is only 2, well, what do we have to multiply 2 by to equal 14? Okay, that would be 7. Okay, so 7 times 2 is 14, and this is also 14. But remember, one of our rules is that hydrogen's coefficient or water's coefficient cannot be odd. Okay, it has to be even, so we have to double it. So instead of 7, we're going to change this to 14. Okay, but because this is 14, my hydrogens are no longer balanced. So 14 times 2 is 28. So if this is 28, then this also has to be 28. 14 times 2 is 28. Okay, so now that hydrogen is balanced and both of them have 28 hydrogens, we can move on to carbon. Okay, so carbon on our reactant side, we have 7 times 2, so that's 14. But on our product side, we only have 1. Well, what times 1 equals 14? Well, 1 times 14 equals 14. Okay, so 14 there. Now, carbon is already balanced. Done. Okay, now lastly, we have to balance oxygen. Oxygen is going to be one of your bigger numbers, and it's also going to be the one that requires the most math. Okay, so 14 times 2 oxygens is 28. So plus another 2 oxygens is 32. So what times, I'm sorry, I am bad at math. Okay, so 14 times 2 is 28. I don't want to be wrong, so I'm just going to get my calculator out. I don't want to teach you wrong either. So 14 times 2 is 28, plus another 14 is 42. Okay, I think I said 32, so that's where I was wrong. Okay, so 42. So we have 2 oxygens on our reactant side, but 42 on our product side. So what times 2 equals 42? Well, it's easier to divide. So 42 divided by 2 equals 21. Okay, so now our equation should be balanced, right? 14 times 2 is 28. 14 times 2 is 28 hydrogens. Carbon, we have 7 times 2, that's 14. Carbon, we have 14 times 1, so still 14. Oxygen, we have 21 times 2, that is 42. And then 14 times 2 is 28, plus another 14, that is 42. Okay? All right, so let's go ahead and do our class practice for balancing combustion equations. Okay, so remember, our first step is to balance hydrogen. Okay, so if I have 8 hydrogen on my reactant side, well, how much does that equal? Or what do I have to multiply with to equal 8? Okay, so 4 times 2 is going to give me 8 hydrogens. Okay, hydrogen is now balanced, so we can move on to carbon. Okay, so carbon here, we have 4. Carbon on this side, we only have 1. So if we only have 4 and 1, then we have to multiply this by 4. Okay, to make it even, to make it balanced. Okay, so now that carbon is balanced, now we can move on to oxygen. Okay, so 4 times 2 is 8, plus another 4 is 12 oxygens. Okay, if I have 12 oxygens on my product side, but only 2 on my reactant side, well, then our answer is going to be 6. Okay, so again, 4 times 2 is 8, plus another 4 is 12. So what times 2 equals 12? Well, 12 divided by 2 is 6. Okay, so this is balanced. Okay, everything else is balanced. Number 2. Okay, again, we start with hydrogen first. So hydrogen on our reactant side, we have 12. On this side, we have 2. So 6 times 2 is equivalent to 12, which will give us 12 hydrogens. Okay, since that's balanced, we can move on to carbon. Carbon is 5 here, but carbon is only 1 here. So our coefficient is going to be 5 for carbon. Okay, carbon is now balanced, so we can move on to oxygen. 5 times 2 is 10, plus another 6 oxygens, that's 16. So 16 divided by 2 is 8. Okay, so we now have a balanced equation. Okay, so number 3. Okay, let's do number 3. So this is where our numbers are going to start to get crazy, because look how big our numbers are. We have 18 and 22, but we'll get to number 4 in a second. Okay, so number 3. We have 18 hydrogens on our reactant side and only 2 on our product side. So for it to be balanced, we're going to have to multiply this by 9 to equal 18. Okay, but remember our rule. We cannot have an odd number for water, and we have to double it. So this is 18. Okay, if this is 18 times 2, okay, which is, let's see, 18 times 2 equals 36. So if this is 36, then this side must equal 36 also. So again, if this is 18 times 2, then this has to be 2 times 18, okay, to equal 36. Okay, so now that our hydrogen is balanced, we're going to go ahead and move on to carbon. Okay, carbon on this side, we have 9 times 2, so that's 18. And since we only have one carbon on this side, then our coefficient has to equal 18. Okay, so now that carbon is balanced, we're going to take a look at oxygen. Okay, 18 times 2, again, is 36, plus another 18, okay, is 54. Okay, so 54 divided by 2 is going to equal 27. Okay. All right. So the last problem, number 4. If you want to try number 4 on your own, pause the video now and try it on your own. But if not, just keep checking through this video. Okay. So number 4, our last problem. Hydrogen, we have 22 on our reactant side. On our product side, we have 2. So what times 2 is going to equal 22? 11. Okay, but remember, we cannot have odd numbers. So we're going to double that to equal 22. Okay, so if we have 22 times 2, that's 44. So we're going to have to multiply our reactant side by 2 as well to equal 44 hydrogens. Okay, now that hydrogen is balanced, we can balance our carbon. Carbon on our reactant side is 22. So if this is only one carbon, then our coefficient has to equal 22. Okay, so now that carbon is balanced, we can move on to oxygen. Okay, oxygen, 22 times 2, that's 44. So plus another 22 oxygens, that's 66. So 66 divided by 2, that's going to be 33. Okay, so hopefully this made sense to you and it wasn't too confusing. Okay, if you do have any questions, please ask.